today's a bit of a milestone in maths methods because after today there really is no other function that you that can be produced that you can't differentiate on the methods exam. So what we'll look at today is the chain product and quotient rule and apply what we now know, which is if f of x equals e to the x, then f dash x will be e to the x as well. And if f of x is equal to log ex, then f dash x, worst x ever, is equal to 1 on x. So a couple of things. Let's find the derivative of this with respect to x. Examiner's report said that you don't always need to fully simplify an expression, but it might make it easier for you on later parts. So we'll see some situations where that might be the case. And this button here, simp, on the calculator really will help you out with some things in exam 2. All right, without further ado, let's go for it. So it's y equals e to the x over e to the 2x plus 1. All right. Now, this is the quotient rule, so I'm just going to write up my u and v. So du dx here equals e to the x, and dv dx here equals 2e to the 2x with the constant chopping out. Hey, don't forget that that's on your formula sheet, so this value here just goes straight to the front. That's the chain rule if you want to apply it. So we'll go dy dx equals, so it's v du dx, so it's e to the x, e to the 2x plus 1, take away u dv dx, so this is going to be 2 e to the x, e to the 2x over v squared, which is e to the 2x plus 1 all squared. Okay, so let's just see what we can do with this, if there is anything that we can do. So we're going to expand this out, so it's e to the x times e to the 2x. So if common bases are multiplied, we add the powers together. So that's going to be e to the 3x plus e to the x. This one here is going to be take away 2 e to the 3x over e to the 2x plus 1. Okay, and can we do anything with that? So this is one lot of e to the 3x, remove 2 lots of e to the 3x. So that's going to be just e to the x, take away e to the 3x over e to the 2x. Oh, I forgot that squared sign, it's naughty. Plus 1 all squared. Now I really think that's the best we can probably do with that. Let's try it on the calc. So shift 7 for define f of x equals. Now we've got, what was the function? E to the x, shift 4 over brackets shift e to the 2x plus 1, close your brackets. So let's do a diff. Okay, yeah, they pull out the negative on the solution. We don't need to do that. In fact, I reckon mine looks better. Let's do a run a simp on it. Probably looks even worse. So yeah, run with my answer. Okay, here we go. Find the derivative of the following with respect to x. So we'll go y equals e to the x times x take 1 to the half. U is equal, so it's product rule. V equals x take 1 to the half. Du dx equals e to the x. Dv dx equals The inside's derivative is 1 multiplied by half u to the negative a half. So it's going to be 1 over 2 x take 1 to the half. All right, and if in doubt, y equals x take 1 to the half, u equals, oops, so we'll go, yeah, u equals x take 1, y equals u to the half, du dx, I'm using the chain rule here if you hadn't noticed, dy du equals half u to the negative a half. That goes down into the denominator, gets multiplied by 1, u sub is x take 1. So there's our derivative. Okay, so dy dx equals, what is it, u dv dx, so it's e to the x over 2 x take 1 to the half. So u dv dx plus v du dx plus e to the x take 1 to the half. Now, it's really common to see further engagement with this problem here on VCAR questions and Cambridge answers. And what the most common one is to see a common denominator and then these combined into one fraction. Okay, so the way we're going to do that is we're going to multiply this. It's currently over 1. We'll times this by 2, x take 1 to the half, over 2, x take 1 to the half. Okay, and what that will do is give this term here a common denominator. So it's going to be e to the x plus, now, so it gets multiplied by 2, so we'll write that as 2 e to the x take 1 to the half times x take 1 to the half, common base, add the powers, it's just x take 1, all over 2 x take 1 to the half. Let's continue it over here. Now what I'm going to do is expand that. Should I expand it? Yeah, I reckon expand it. E to the x, so equals e to the x plus 2x e to the x, take away 2 e to the x. So I've just run the distributive law there and there, over 2 root x take 1 equals, now this is 1 lot of e to the x, take away 2 lots of e to the x. This we can't do anything with, so we're going to go 2x e to the x, take away e to the x, over 2 root x take 1. We could factor out the e to the x on that, so let's do it just for whatever reason. Alright, so basically there's our final answer, but just sort of note that this answer here, before I found the common denominator, is a perfectly acceptable and functioning derivative, but it's just worth further engaging just to check out, you know, some of the other moves that you can make. Alright, you can remember the following rule, but why remember rules? If h of x equals e to the f of x, then h dash x will be f dash x multiplied by e to the f of x. I've never even heard of that rule, but anyway, there's a common way I do these ones where we've got a function inside a function and we don't know what one of the functions are or is. So I'm going to say that y equals f of e to the x, y equals the function f of u, where u is equal to e to the x. dy dx equals f dash u, du dx equals e to the x. So this is the chain rule, so we're going to multiply them. So we're going to say that dy dx equals that multiplied by that, so it's f dash e to the x, you substitute that, multiplied by e to the x, and there's our derivative. Okay, so you don't actually have to have a function to get a derivative. Okay, given that g is a differentiable function and k is a real number, the derivative of the composite function that is. So this is exactly the same question as before. So it's just going to test whether you can recognize that this is the chain rule. So we've got y equals g of e to the kx. Y equals g of u. So u is our inside function, where u is equal to e to the kx. dy du is equal to g dash u, and du dx is equal to, by the rule on your formula sheet, k e to the kx. dy dx therefore is equal to these multiplied by each other with a u substitution. So k e to the kx, g dash e to the kx. K to the kx, g, no, that should be g dash for it to be right. Not on any level. K to the kx, g dash, no, that needs a k there, that's gone. I think it's a. K, yeah, so all they've done is that has been swapped because it's just multiply. So that is, the derivative goes first and then e to the kx goes second. Yeah, definitely A. Okay, if the tangent to the graph of y equals e to the ax pass at x equals c passes through the origin, then c is equal to. Alright, so basically let's imagine e to the ax, so it could look like that. And at c, so here's a possibility. So at C there's a tangent drawn, and what that tangent does, that's pretty bad tangent, but what it does at point C, which is there, it's going to go through the origin. So it goes through 0, 0. The other one it goes through is C, comma, like I don't know what the point is, C, comma, e to the AC. Okay, so at point C, the y value is x equals c. Alright, then what we're going to do is get our derivative at point C as well. So if y equals a e to the ax, then dy dx is going to be a e to the ax sub x equals c, dy dx equals a e ac. Okay, so what we've got is coordinate 1, coordinate 2, and gradient at the point. This then is going to mean that we're going to use this formula: y take y1 equals m, x take x1, the gradient or the equation of the tangent. Okay. Now what I think will happen is we'll get a whole heap of cancellations once we start subbing this stuff in. Let's just see. So we will go y, so this is e ac, take away 0, so it's just, I'm not going to even do it, a e ac, and x value is c, there. Okay. So what are we solving for? Passes, then c is equal to, so we're going to solve for c. So all we'll do is we'll go EAC over A EAC equals C. Now that cancels with that, leaving 1 in the denominator. So C is equal to 1 on A, which is B. Alright, so now that we've used e to the x, let's just start using some logs. Okay, so log ex. So first thing to note, we've got product rule. Y equals x squared log ex. u equals x squared, v equals log e x. Du dx equals 2x, dv dx equals 1 on x. The rule is on your formula sheet. So dy dx is u dv dx. So those multiply, which is x squared over x, which just leaves us with x, plus that multiplied by that. Pretty easy one, that one. Okay, so quotient rule on this one. So u is equal to x squared, v is equal to log e x, du dx equals 2x, dv dx equals 1 on x. So it's going to be v du dx v du dx, take away u dv dx, which is x squared over x, which is just x, over v squared, which is log e x all squared. Nothing we can do with that. Yeah, that's alright. Alright, here's another one, 2013 Methods Exam 2. Part of the graph of the function shown. So these, when you multiply an exponential by a trig, what you've got to understand is what it does. So the exponential e to the x, that is this graph here with an increasingly large value multiplied by the standard sine graph, which looks like this. And what this will do is, as x gets bigger, the amplitude gets bigger, and it creates what they call, I think it's called a dampening, or not a dampening, but the opposite to a dampening function. So it starts small, gets bigger, it's bigger as the amplitude gets bigger, because e to the x gets bigger, it just goes up further and further and further. Okay, so that's what's going to happen here. So this is one cycle of the function, and I can see here that this is going to be 2 pi. So this is going to go up, and then it will sort of come down again like this, right? And it will end up here at 4 pi. So the first 3 turning points are labelled T1, T2, and T3. What we're after is the x-coordinate of T3. So I think all we'll do is just type that into the calculator and run a diff, solve x equals 0, and then look for the third stationary point over the domain 0 to 4 pi. Alright, so let's go for it. Shift 7 for define f of x equals Shift E x times Shift root times, make sure you go back down into, or out of the exponent, multiplied by Shift 1, I think, yeah, sine x. Okay, so there's our function. So let's diff it. So it's this huge thing. Doesn't really matter what it is. Solve. Shift ants equals 0 for x, please. Shift 9 for the restricted domain shortcut that we've got set up between 0 and 4 pi. So there's the first stationary point at 5 pi and 6. That sort of seems to make sense. 11 pi and 6, so almost 2 pi. And then we've got our third at 17 pi on 6. So the x value there should be 17 pi on 6, which is that one there. And we get one final one, which is this one here at 23 pi on 6. So yeah, there you go. Good calculator question, that one. Okay, given that f of 0 is equal to 6, f dash 0 is equal to 2, find dy dx of that, and when x is equal to 0. So this information here, I'm not worried about yet. Let's just get our derivative first. sub in x equals 0 and see what happens then. Okay, so our function is y equals log e f of x. Okay, so that's our u. So our u is equal to f of x, where y is equal to log e u. Du dx equals f dash x. Dv dy du is equal to 1 over u. Now these get multiplied for dy dx. Equals that by that with a u sub, so it's f dash x over f of x is u. That's that there. So we're going to sub x is equal to 0 into this, so dy dx equals f dash 0 over f of 0. Now this is important, so f dash 0 they've told us is 2 over f of 0 is 6, so it is 1/3 at x is equal to 0. Okay, what is the derivative of log 10x? Now we know that if f of x equals log ex, then f dash x is equal to 1 on x. What we don't know is how to derive log 10x, but there's this really cool rule called the change of base rule. Okay, so if y is equal to log 10x, then what we can do is rewrite that as y equals log e, that's the chosen base, x over log e 10, okay, the original base. So remember, chosen base goes here, x goes there, and 10 goes there, the change of base rule. All right, now, why did I choose base e? Because I know it's easy to derive. So what I'm going to do is just rewrite this one more time as 1 over log e 10 times log e x. And this value here, all it is a constant, okay? 1 over log e 10. So I can treat it like the number 2, the number 7. It works exactly the same way. So I'm ready to derive this. Dy dx equals 1 over log e 10 times the derivative of this, which is just 1 over x, equals 1 over x log e 10. Right, so there's our derivative. Haven't seen them ask a question where you have to derive something other than log base e, but yeah, that's not to say they won't do it this year. Okay, express 2 to the x in the form e to the kx, hence find the derivative of 2 to the x. Okay, so basically we want to write this base e so that we can find the derivative of 2 to the x. Because remember, f dash x, if f of x is e to the x, then f dash x is e to the x. It's easy to derive. Okay, so if y equals 2 to the x, another way of writing it is to use this particular rule, which is log no, that's not the rule I want, which is e log e to x. Alright, so remember e log e to x is just 2x there. That undoes itself if you want to think about it like that. Right, now I'm going to grab that x and stick it out the front, so that's going to be y equals e x log e2. Better still, what I'm going to do is stick the coefficient at the back. Y equals e log e2 x. Alright, so that's just a number, okay? So if I said to you, hey, derive e log 2x, what you would do is go dy dx equals 2e to x. Alright, that would be easy. So this is exactly the same thing, so don't overthink this one. So this is e log, that should be an e if you can't read it, e2. So dy dx is therefore going to be this thing here goes out the front, log e2 times e to the log e2 x. All right, so it's as simple as that, and there's our derivative. Okay, determine the equation of the tangent to the curve. Do you know what? What I'm going to do is leave this question because this is an X, or a chapter rather, chapter 10 style question, applications of diff. And same as this one here, the number of people, rate of change, and average rate of change. This is also a chapter 10 style question. So I'm going to leave that for next week, actually. We'll cover that next week. So there are the questions. Also, all of the worksheets now are fair game. In fact, try yourself out. Any derivative on a VCAR exam can be done by you now after this lesson. So that's a pretty cool thing to have happen.